Hello everyone. Welcome to the next lecture on the CSIR NET mathematics paper. Today I will cover all those questions related to the initial value problem. This initial value problem belongs to the numerical analysis. It also belongs to the ordinary differential equation, partial differential equation and many more. Wherever in the part B the initial value problem mentioned, I will cover in this lecture. Myself Dr. Harish Garg. You can follow my YouTube channel where you can find the playlist of CSIR UGC NET, and you can see that the last three lecture was on complex, real and the linear algebra related to the part B. Apart from them, you can also watch the another lectures which are already explained with the help of the fully shortcut tricks. I use that shortcut tricks again in this lecture to explain the methods. Don't forget to subscribe my YouTube channel so that when I uploaded my next lecture, you will get the notification. Now, the first question is related to the initial value problem belongs to the numerical analysis. So if I try to compare this equation with f of x comma y, then my solution will be my f of xy comma is x into y plus 1. Now, if you read the statement, if the value of the approximate solution at the point y of 0.2 by the Euler modified method by the Euler method is given to be 1.02 with the step size 0.1. That's over, very simple. You all knows what is the formula for the Euler method. What is the Euler method is y of n plus 1 is yn plus h times xn comma yn. So now let's do that. What is the y1? Y1 is y0. Y0 is my beta plus h. What is the f of x0 comma y0? That is a beta. And you know that what is the f of 0 comma beta is 0. Answer is beta. Can you find the value of the x1? That is the x0 plus h. Now your target is to find the y2. What is the y2 is y1 plus h f times x1 comma y1. Y1 is my beta. Now you can substitute the value. What is the y2? Y2 is my 1.02. Y1 is my beta. It is 0.1. This is x into y plus 1. So that will be 1.01. It is beta plus 0.01 times beta plus 0.01. I can subtract them. This will give you 1.01, which is 1.01 times beta. So what is the answer of the beta? Is my 1 is the right answer of this problem. You can see that this question is one of the easiest question in the numerical analysis. That's why this question look like so very funny as of this picture. If you want to find more detail about the Euler method, I recommended you must watch about my this Euler method. I have explained you with the help of the shortcut tricks. So you can see that within a couple of seconds you can get your right answer in the examinations. Look at the second example. Consider the initial value problem. Y dash is root of absolute value of y plus epsilon, and this solution is given to be more than one solution, Now listen carefully, very students, listen carefully. If you read the statement, does they ask you to solve the problem? Does they ask you to solve the problem? No, because they are simply saying whether it's a true or false. They are simply asking you whether the unique solution or more than one solution. Fine. So which things come in your mind when you think about the initial value problem? Do you remember any of my lecture? Yes, you always remember my uniqueness and existence lecture. And what is the shortcut tricks? As I told you, this is my shortcut tricks for you. Fine. And I already explained all these examples with in these lectures with the help of shortcut tricks. Now it's a more than one solution, that is infinite many solution. This will happen only when, according to this case, y0 will be my 0. Fine. When y0 will be 0, you have infinite many solution, and whenever y0 is my greater than 0, then you have the unique solution, provided what is the alpha? Alpha is my half, but in this case it's a modulus. Fine. So this question is related to this one, but how you can transform them? Now you can see the approach. First of all, I can simply choose h is y plus epsilon. Fine. Then clearly say this differential equation h dash is my this part. Clear? Now look at the options. There is an epsilon greater than 0. So I can choose any of the epsilon. You can choose one. Fine. Then for all y naught which belongs to the R, then first of all, what is the h mode? So there are the two choices. If h is my less than 0, then this number will be complex number, and then there is no real solution. Fine. And if h is greater than 0, then we will get as a root of h. If h is equal to 0, then we will get as a 0. This is the cases for the h dash. Fine. Now, so this case we can rule out because there is no real solution apart for that. Now, when this will happen, so this case, what is my f of x comma y is a root of h, where h is my y plus x. Then what is the partial derivative with respect to h? 1 over root h into h dash of y is my 1. Or you can say, if you differentiate this with respect to y, this is h with respect to y is my 1. Now, when this will give you the unique solution, if you prove that it is a bounded, that means Lipschitz is continuous. And if you prove that this is unbounded, then you will get as infinitely many solution, and in this case you will get a unique solution. Now clearly say what is the h? H is my y plus epsilon. If I choose epsilon is my 1, then definitely if I choose epsilon, y is my y naught initial point, any number which is greater than of the minus 1, then what is the value of the h at the point of x naught y naught? This number is my always greater than 0. Once this number is always greater than 0, that means this number is my bounded. That means you will get the unique solution. However, remember that more than one solution, that is infinite solution, only when you get as a 0. But remember, he said for all y naught. Fine. So once he said for all y naught, you can choose any y naught. Let's say y naught is my 3. When y0 is 3, then it's satisfied by this property, then it is a unique solution. So more than one solution always is not the correct answer. Now look at the second option. What is given to you? Now you have to choose y naught firstly. You can choose any y naught, say any real number, say minus of 1, or you can choose any real number 3. Fine. Then such that now this case for all epsilon, it has a more than one solution. Again for this case, what will happen for the h for all epsilon greater than 0? If I choose y naught as a minus 3, for example, then if I choose epsilon is my 3, then in that case h will be 0. If h will be 0, then this case is my unbounded. Fine. If this is unbounded, then we have the more than one solution. But is it true for all epsilon? No. If I choose y naught is my minus of 3, epsilon is my 7. Is it satisfied? Then clearly say h is my positive, and in that case you will get as the bounded. That means a unique solution. Therefore, you will get a more than one solution always not possible. You will get a unique solution only in the one case. What is the case is whenever this y naught plus epsilon is my 0. That means whenever you will choose y naught is equal to minus epsilon, then only in that case your this function is my unbounded, and once is unbounded you will get as the infinitely many solution, because no solution is not possible. Y naught is given to you as a one solution, so no solution is not possible, only infinite solution is given. So that is the only one case. But is it true for all epsilon? No, because if you choose y naught is say 7 minus 7, epsilon is my plus 7, that's satisfied. But if you choose epsilon is my 71, then it is my unique solution. So both the options are wrong. That is fourth is my correct answer of this problem. This question is similar to my shortcut tricks. The only thing is they have used the term epsilon. Fine. They have used epsilon, so that's why you have to think about this similar method. I hope you can like, share, and comment on my this video as well. Now, look at this another question. What is given to you? Ut is my uxx. Remember that? Which condition? Yes, it's a heat equation. And what is a heat equation and what is the solution of that? First of all, I will tell you the shortcut tricks. If it is my sine of nx, then what is my solution? Solution will be, if I call as a c square, it is minus n square c square into t of sine nx. This is the shortcut tricks I explain you in my this lecture. This is the very strongly recommended you if you watch this lecture, you can get your answer in a 15 second. Fine. Now, but you can see that x plus 1 is the extra term. Very simple. I can remove this part. If I define v to be u minus x plus 1, that means if I define the term v is equal to u of x comma t minus x plus 1. Fine. Now clearly say what is my differential equation. What is the partial derivative with respect to t? Is v of t. Partial derivative with respect to xx is a 0. Then it will be my u of tt. Fine. Then what is the value of the initial condition? X comma 0. What is x comma 0? This case x 1 plus cancel. It's a sine of 4x. Fine. Now it's a complete heat equation. So I can solve this equation. What is the solution of this problem? E raised to power minus 16c is my 1 minus and sine of 4x. So what is the solution of the u x comma t? That will be e raised to power minus 16t. That is a v of xt plus x plus 1. The similar kind of the question I already explained and solved in this heat equation. You must watch about my this lecture. Now that's over. Now your target is to find the values of the pi by 8 comma 1 and your target is to find the values at minus pi by 8 comma 1. So what is the answer of the pi by 8 comma 1? It's a e raised to power minus 16. Pi by 2 is a 1 plus pi by 8 plus 1 is a minus pi by 8 is a minus pi by 2. Minus pi by 2 is my minus 16. Minus is a minus pi by 8 plus 1. Clearly say they, first of all, is it a negative of this? No. If you take a negative common, then it will be the negative. Clearly say if you add them, it will be my 2. So the first option is correct. This option is cancelled. If you twice of this, if you multiply by 2 and add them, it will not be a 2. So this option is also cancelled. A is my right answer of this problem. You can see that there is no need to think much in the examination if you already watch my this lecture of the heat equations. Remember student, if you watch right now this lecture, you will see that the same question I have explained in this lecture as well. Don't forget to like and comment on this video. Now again, it's an initial value as well as a boundary value problem. So firstly, I can write this in the simplified form. This is x y double dash plus y dash minus 2y dash plus y over x is my 1. If you take the LCM, it is x square y double dash minus xy dash plus y is equal to x. Do you remember which equation is? It's a Cauchy-Euler equation. Fine. Then you can simply take x is e raised to power z. Then your equation will be m square minus m and m, that is a 2m plus 1, which is equal to e raised to power z. Fine. Now can you write the solution? Is roots are my 1 and 1. So solution is c1 plus c2 times z e raised to power z. Can you find the particular integral? So it is 1 over d square minus 2d plus 1. Now it's a case of failure. Twice of the case of failure is a 2 e raised to power z. So my final solution will be c1 plus c2. Z I can change into the form of the ln x or log x. This is my e raised to power z is x plus z square. Z square is my ln of z square divided by 2 into x. Then your target is to find the values at the e. What is the answer of this? C1. Log of e is 1. This is e. Log of e 1. 1 square is 1. So e over 2. So definitely the answer will be divided by 2. So this option may not be the correct option. Fine. Now I can apply the y of 1 0. What is the meaning of the y1 0? So this is x. Log 1 is 0, log 1 0, that means implies c1 is 0. So that means this part is 0. If I apply y of e raised to power 4, so that will be c1 plus 4 times c2 e raised to power 4 plus it's a 4, 4 square is 16, 16 by 2 8 e raised to power 4. C1 is also 0 and this value is come to be 4 times e raised to power 4. So clearly say, if you can you find the value of the C2? Clearly say C2 is my minus 1. So if I substitute this value, minus E plus E by 2 minus E over 2 is the right answer of this problem. It's a Cauchy-Euler equations and you can easily solve this problem in the examinations. For more detail, you can watch my these two lectures on their differential equation, all again with the help of the shortcut quiz. Now look at this another problem. Again this problem is my initial value problem and the function is given to be as 2024 of ux. What come in your mind when you see this equation? That is a Cauchy equation. Fine, in the partial differential equation, and you have already watched my this lecture how you can solve them. Now it's a dx, it's a dt, it's a d of u. U is my 0, dt is my 1, this is my 2024. From the first two cases I can get this my solution. This is my constant. From the last case I can taken as a u is my C2. So therefore my solution is x minus actually there is no role of the 2024 because this year is a 2024, that's why it is written as a 2024, which is my u. Fine. Now apply the initial condition. U, that is a x, which is equal to u0 of x. I can substitute this value, and if you remember that the same question is already asked in the last year paper, I think in the 2022 or in the 2023. So that is a u0 x minus 2024 t. Fine. That means the behavior of the u and u naught is similar, or you can say this function x comma t is map on the I call this is say my y. Fine. A two tuple is map on the single one. Now that's over. Now I can write this solution at this upside, so that I can take the options and discard which one is the wrong option. X minus 2024 of t. Now what is the u? U is any arbitrary continuously differentiable function. So what is the continuously differentiable function? I can choose a linear function. Fine. I can choose this is my x, or you can choose as a quadratic function, you can choose as a continuous cubic function, you can choose as a sin x function, but the easiest one is my sin x. So therefore this function is my this part. Fine. So now my solution is this case. Fine. Now you can check about the option S1. If AT, what is my AT is collection of all those x such that u x comma t, that is x minus 2024 t is my less than 1, and a of t denotes the Lebesgue measure. That's very simple. Now you can see that your target is to find the values of the x. What is the graph of the, just forget about that, this is the value of the y. I have drawn the graph of this x minus of this is the value of the u is equal to 1. Fine. This is my u. I draw the graph of this. Now for what value of the x it will be less than of the 1. This is the case. I call this is my a comma b. Fine. So what is the length of this? It is basically an interval of a comma B. What is the A0? If you define as the A0, that means collection of all those x, that is a t is equal to 0. Fine. If you draw the graph of the y is equal to x, and okay, let me write you again here. This is the graph of y is equal to x. For example, can you draw the graph of y is equal to x minus a? So definitely, this is the graph of the x minus a. The same thing they are asking here. Look at that. This is the x minus, because you can see that it is for every t. That means small t is my fixed number. Fine. So let me draw this graph again for you this side. Firstly, this is the graph of x. Fine. This because this 2024t is a fixed number, so I can code as a x minus a. So this is the graph of the x minus a. This is the value of the u is equal to 1. What is the meaning of that? That is simply shifting the origin. Fine. And this is the value from a to b of the at, and this is the value of, so if you are just shifting the origin, look at that, if you are shifting the origin only, then if your at will be my a comma b, what will be my a0? A0 is again a comma b. Why? Because you are just this map to this point and this map to the this point. Fine. So what does it means? That is the length is my same. So once the length is same, and then they are asking the same thing. So S1 is the correct option. So S1 is false, wrong. S1 is false, wrong. Now second option. If u0 is the Lebesgue integrable, then for every t, that's a t is my fix, the function x will map to u x comma t is also Lebesgue integrable. Now you can see about that, the same condition about that. Fine, because t is my fixed number. So again, you can see that this is shifting the origin. So the behavior of the integrable is remain the same. So yes, if u0 is my integrable function, if u0 is my integrable function, fine. So if this function is my integrable, fine, and what is the difference between them is they are just shifting the origin, so that means they are also the Lebesgue integrable. That's true. So both are my correct option of this problem. So that's true, that's a Cauchy problem, but there is a slightly relation with the Lebesgue measurable theory. So that's a combination of the Cauchy problem and the Lebesgue measurable theory. But that's an interesting question. That's side true. This side in this year the Cauchy problem is a little bit difficult for this part. And in this and in the examination, you have to know the shifting property come in your mind in your 5 minutes or within the 2-3 minutes in the examination. I hope you can simply remember these tricks for the future purposes and for this year purposes. Don't forget to subscribe my YouTube channels and to support my efforts. I hope you can like, share, and comment on this video too. Best of luck, students. Happy learning.